Hi, and welcome to our summary notes to kind of wrap up this unit. Since there are kind of a lot of trends that you need to be aware of and know, I thought it was helpful to put together a couple of little charts that will kind of help summarize these for you. It's important to understand what you can look up in this unit versus what you actually just need to memorize and the things that you need to be able to interpret. Electronegativity and ionization energy. From left to right. So I'm kind of just going to essentially make this huge arrow saying anything that goes this way, does it increase, does it decrease? Just to summarize everything in one nice little place. So electronegativity and ionization energy, as we go from left to right, are both going to increase as atoms get better at holding on to electrons. Nuclear charge is going to increase as well. Atomic radii, remember, is decreasing, and metallic character is decreasing as well. Just to kind of leave you a little note with each of these, electronegativity and ionization energy on table S. Nuclear charge is the number of protons, that's the periodic table. Atomic radii is on table S. Metallic character, you need just need to know. Pretty easy to figure that out. You're going from the metals to the nonmetals. In terms of something else that you do need to know, you can look up all of these trends. What you do actually need to know about atomic radii is you need to know the reason behind it, which again is that increasing nuclear charge, pulling in those rings of electrons tighter. As we go from bottom to top, anytime that we're in this, or I'm sorry, when we talk about electronegativity and ionization energy, as we go up a group, these would both be increasing. Down a group, they would decrease, so you're just kind of reading these the opposite if you're looking at it that way. Nuclear charge we don't really look at as a group trend so much, but remember, it's just your number of protons, so that would be decreasing as you go up, but this isn't really one that's particularly important looking at it in a group sense. Atomic radii from bottom to top is going to be decreasing. You're getting smaller due to your fewer number of rings of electrons, and your metallic character is decreasing as well. And remember, metallic character you do need to know. The other trend that you need to really know is what happens to cations and anions. So this is what is called ionic radii, and this involves electrons being gained or lost. So if you have a cation forming, it is lost electrons. It is going to get smaller. So if you look up the atomic radius, which you actually have a number for, you have somebody like sodium who loses electrons, they will get smaller when they form a cation. Anions are going to get larger. So you have more repulsion when you have more electrons, therefore they kind of swell out and get a little bit bigger as ions. Again, table S, you can do atomic radii, electronegativity, and ionization energy. Those are kind of the big trends that we talked about that are on table S. And then nuclear charge is the periodic table, so that can be helpful as well. Not on table S is going to be ionic radii. So you need to know who gets smaller, who gets bigger, and also metallic character you need to be familiar with. Remember, metallic character relates to how well something holds on to electrons. So if an atom holds on to electrons really well, it has low metallic character. If it does not hold on to electrons well, it has high metallic character. Just an overall property summaries chart. Metals will form positive ions, nonmetals negative. Noble gases do not form ions typically. Metals don't hold their electrons well, they lose them. Nonmetals are more likely to gain them. In some cases they share them, but they don't lose them. And noble gases are non-reactive. Electronegativity and ionization energy are low for the metals. I like to say low left, lose. Metals on the left side, low electronegativity, lose electrons. Nonmetals, on the other hand, are high. There's not a value for electronegation for the noble gases. They're left off that arbitrary scale. Ionization energy can be measured, and it's really, really, really ridiculously large. Metals are almost all solids in STP except for mercury, which is a liquid. Nonmetals can be solid, liquid, or gas. You need to know who's who. In some classes, some science classes in your earlier years, sometimes the nonmetals are referred to as gases, but they're not all gases. And the noble gases are gases. So that's pretty easy. An important property to understand is who conducts, who doesn't. Metals conduct heat and electricity. Nonmetals do not. And noble gases do not as well. Other general properties to have an understanding of is that your metals are going to be ductile, lustrous, and malleable. That's actually due to the mobility and that weak holding of electrons. We'll talk about that in our bonding unit. And nonmetals tend to be softer or brittle. Sometimes they're gases. Nonmetals have a lot of variety in their properties, but they don't conduct. And our noble gases are indeed gases.